There are dinosaurs here. No.
Depth of 1,120 feet underground. This makes Ruby Falls the deepest commercial waterfall in the United States. Ruby Falls.
What do you mean? Pretty cool. No, you're not. This is the green.
Waterfall! I'm Anil Kumar. I hope you really enjoyed the video. A journey through the caves, amazing structure of stalactites and stalagmites, and at the end, the great Ruby Falls. Now, based on this, I have created a word problem for you. It's an application of sine and cosine law. So let's go through the question. I am sharing with you a video on the amazing Ruby Falls inside the magnificent limestone cave with rich display of stalactites and stalagmites. Ruby Fall is around 145 feet. I estimated angle of elevation of 85 degrees from a point A, then walked 15 feet to point B to estimate the angles formed by the triangle AOB on the horizontal floor of the cave. If O is a point directly below the waterfall and the estimated angles are 45 degrees and 55 degrees as shown in the figure below, find the percentage error in the calculated height of the waterfall. So I hope the question is clear. So we are given an angle of elevation of 85 degrees, the two other angles measured along a line AB to the point where I have assumed water to be falling as 45 and 55 degrees. The distance between these 2 points is 15 feet. Now from here you can find the height of this waterfall. Once you find the height, then you know the actual height is 145 feet. So in your calculations, you have to now find out the percentage error in the calculation. Then the choices are, is the percentage error less than 2%, between 2 to 6%, between 6 to 10%, or more than 10%? So I hope now the question is clear, right? Okay, pause the video, answer, and then look into my suggestions. So our approach is going to be first to find this angle at O. So the triangle AOB, we are given two angles. The third angle has to be 180 minus these two. So that gives us 180 degrees. Take away 45 degrees. Take away 55 degrees. So that gives you how much? That gives you 80 degrees as the angle at O. So this is the angle AOB, right? Once you find the angle, which is 80 degrees, you have one set with angle and side length of the opposite side. And therefore, you can now apply the sine law, correct? So after this, you apply the sine law and find the length AO, correct? So when you apply the sine law, what do you get? You get AO over the angle opposite to AO, which is 55 degrees, sine of 55 degrees, is equal to what is given to you, 15 over sine of 80 degrees, correct? So from here we can find the distance of point A from the point where the water is falling, which is AO. So let me write here AO is equal to 15 over sine of 80 degrees times sine of 55 degrees. So that gives you the distance AO. Let's use calculator to calculate this value. It's 15 times sine of 55 degrees divided by sine of 80 degrees. That gives you 12.4768. So let me write 12.4768. Let me write 477. All these dimensions are in feet. So we get the length AO. Now we have to find the height of the waterfall. Correct? So let's go on to the next page. Write down whatever we have got here and then continue to find the height and then the percentage error. Perfect. Okay, so let's redraw what we had there, and then we are going to calculate the height. So I'm just making a sketch here. So this was the angle of elevation of 85 degrees, and we just found this length AO as 12.477, correct? So that is very important for us, and what we had here earlier was these two angles. So the angles were 55 and 45 degrees. This side is 15 feet, correct? Now we need to find height, and that is at right angles. Perfect. So this is A, O, and B. So now let's find height from the given situation. So we can use tan. So tan of 85 degrees is equal to height over AO, which is 12.477. So from here we can calculate height as 12.477 times tan of 85 degrees, right? So let's use the calculator. We already have the value. We'll just multiply by tan of 85 degrees. So we get 142, which is fairly close to 145, correct? So that much feet we get. That's a fairly good estimate, right? So height is estimated as 142.6. Now let's find the percentage error, right? So that is the next part of this question. So percentage error is what we have estimated. So it is 142 minus 145, which was the actual height, divided by 145, right, times 100. So that becomes the percentage error. So let's calculate the percentage error. It's definitely less than 2%. 142 minus 145 divided by 145 times 100. That gives you in decimals a value of 2.06. So it's kind of tricky. It's almost 2%, right? So, okay. So if I take this value slightly closer to 142.6, let's redo, right? 142.6, and then we take away 145, divide by 145 times 100, right? Then let's calculate. So it is 142.6 minus 145 equals to, divide by 145 times 100. So in decimals, this time we get minus 1.655. So you see how important it is to consider the decimal values, otherwise you may get the wrong choice, correct? So negative means that our estimate was lower, so however it is around 1.65%, right? So choice A is the right choice. Perfect. So as I have shown you here, you should use decimal values to at least 2 places. If you don't do that, you may just mark the wrong thing. So I hope that helps to understand the situation and also appreciate how accurately we should be doing our calculations to take the choices, as these are calculated values where in test you might just make a mistake. I hope you understand and appreciate what we've done here. Feel free to write a comment, share your views, and I hope you enjoyed the waterfalls and also the learning process. Thanks for watching and all the best.